Department of Studies in Library and Information Science, University of Mysore, Department of Studies in Computer Science, University of Mysore, and the Sarada Ranganathan Endowment for Library Science, the Shades. We are gathered here this morning for the Sarada Ranganathan Endowment Lecture 2025, a prestigious academic event that carries forward the rich legacy of the father of library science in India, Dr. S.R. Ranganathan, whose contributions continue to inspire generations of library and information professionals. To begin the program on an auspicious note, may I request Vaishnavi and team of the Department of Computer Science to render the invocation.
ಶರಣು ಶರಣಯ್ಯ ಶರಣು ಬೆನಕ ನೀನಯ್ಯ ಬಾಳೆಲ್ಲ ಬೆಳಗುವ ಬೆಳಕ ಶರಣು ಶರಣಯ್ಯ ಶರಣು ಬೆನಕ ನೀನಯ್ಯ ಬಾಳೆಲ್ಲ ಬೆಳಗುವ ಬೆಳಕ ನಿನ್ನ ನಂಬಿದ ಜನಕ್ಕೆ ಹುದಯ್ಯ ಎಲ್ಲ ಸುಖ ತಂದೆ ಕಾಯೋ ನಮ್ಮ ಕರಿಮುಖ ಶರಣು ಶರಣಯ್ಯ ಶರಣು ಬೆನಕ ನೀರಯ್ಯ ಬಾಳೆಲ್ಲ ಬೆಳಗುವ ಬೆಳಕ ಎಲ್ಲಾರು ಒಂದಾಗಿ ನಿನ್ನ ನಮಿಸಿ ನಲಿಯೋದು ನೋಡೋಕೆ ಚೆನ್ನ ಎಲ್ಲಾರು ಒಂದಾಗಿ ನಿನ್ನ ನಮಿಸಿ ನಲಿಯೋದು ನೋಡೋಕೆ ಚೆನ್ನ ಗರಿಕೆ ತಂದರೆ ನೀನು ಕೊಡುವೆ ಬರಬಲ್ಲ ಗತಿ ನೀನೆ ಗಣಪನೆ ಕೈ ಹಿಡಿಯೋ ಮುನ್ನ ಶರಣು ಶರಣಯ್ಯ ಶರಣು ಬೆನಕ ನೀಡಯ್ಯ ಬಾಳೆಲ್ಲ ಬೆಳಗುವ ಬೆಳಕ ಸೂರ್ಯನೆದುರಲ್ಲಿ ಮಂಜು ಕರಗುವ ರೀತಿ ನಿನ್ನ ನೆನೆಯಲು ಒಡನೆ ಓಡುವುದು ಭೀತಿ ಸೂರ್ಯನೆದುರಲ್ಲಿ ಮಂಜು ಕರಗುವ ರೀತಿ ನಿನ್ನ ನೆನೆಯಲು ಒಡನೆ ಓಡುವುದು ಭೀತಿ ನೀಡಯ್ಯ ಕಷ್ಟಗಳ ಗೆಲ್ಲುವ ಶಕುತಿ ನೀಡಯ್ಯ ಕಷ್ಟಗಳ ಗೆಲ್ಲುವ ಶಕುತಿ ತೋರಯ್ಯ ನಮ್ಮಲ್ಲಿ ನಿನ್ನಯ ಪ್ರೀತಿ ಶರಣು ಶರಣಯ್ಯ ಶರಣು ಬೆನಕ ನೀಡಯ್ಯ ಬಾಳೆಲ್ಲ ಬೆಳಗುವ ಬೆಳಕ ನಿನ್ನ ನಂಬಿದ ಜನಕ್ಕೆ ಹುದಯ್ಯ ಎಲ್ಲ ಸುಖ ತಂದೆ ಕಾಯೋ ನಮ್ಮ ಕರಿಮುಖ ಶರಣು ಶರಣಯ್ಯ ಶರಣು ಬೆನಕ ನೀಡಯ್ಯ ಬಾಳೆಲ್ಲ ಬೆಳಗುವ ಬೆಳಕ ನೀಡಯ್ಯ ಬಾಳೆಲ್ಲ ಬೆಳಗುವ ಬೆಳಕ ನೀಡಯ್ಯ ಬಾಳೆಲ್ಲ ಬೆಳಗುವ ಬೆಳಕ.
Thank you, Vaishnavi and team, for the melodious and grace-filled invocation. To formally welcome the gathering, I now invite Professor K.S. Raghavan, Member Secretary, Shales, and former Professor, Madras University and DRDC, to deliver the welcome address.
Dignitaries on the as Professor Guru, the chairperson of this program, Professor Ricardo, Baeza-Yates, Professor Hanumantaka, Dr. Harinarayana, Professor Shalini Harus. Distinguished invitees, members of faculty, students, research scholars, and media personnel present here. At the outset, on behalf of the organizers of this lecture program, the Sarada Ranganathan Endowment for Library Science, the University of Mysore Departments of Computer Science and Library and Information Science, I welcome every one of you present here in such large numbers. The Sarada Ranganathan Endowment for Library Science was founded in 1964 at the instance of students of late Professor S.R. Ranganathan to promote research in library and information science, conduct continuing education programs, organize lectures by eminent information scientists. It was in the initial years guided and nurtured largely by Dr. Ranganathan himself. Dr. Ranganathan was a national research professor at that time, and he was one of the 4 national research professors recognized by the government of India. At that time, there were only 4 national research professors. Dr. Ranganathan and Sir C.V. Raman were 2 of these. There were 2 other, one from literature and one from some other discipline, I don't remember. The Endowment has been conducting and organizing various programs to advance information science and information service. Beginning with a lecture by Dr. Bernard Palmer of UK way back in 1964. The Endowment has hosted many eminent information and library professionals, computer scientists, and management scientists. The list reads like who is who in the information field. Dr. Jesse Scherer was dean at the Westminster University in United States of America. Dr. Eugene Garfield was founder of the Institute for Scientific Information. Professor Elaine Svenonius of the University of California, Los Angeles, just to name a few. In the recent years, we have had Professor Gary Marcioni of University of North Carolina, Chapel Hill, Professor Joseph Dennis of the High School, University of Washington, Seattle, Professor Shiryo Sugimoto of University of Tsukuba, Japan, Dr. Caroline Waters of University, Dalhousie University in Halifax, Canada, and Professor M. Anandakrishnan was Vice Chancellor of Anna University. In recent years, they have delivered lectures under the Endowment. Indeed, it's a very long list. There is runs to about 50 to 60 names. At the dawn of this century, the American Library Association chose to compile a list of most impactful library and information professionals of the 20th century, and they did publish 100 American library and information scientists who had maximum impact on the profession, information science and service in the 20th century. They added as the 101st name Dr. S.R. Ranganathan, the only one from outside the United States of America to be added to that list. We are indeed extremely happy and deeply honored that Professor Ricardo Baeza-Yates, who is a very well-known figure in the field of information retrieval and computer sciences, he has accepted our invitation to deliver the 2025 Endowment Lecture on a theme which is of great contemporary interest. Friends, I invite every one of you to join me in welcoming Professor Baeza-Yates. I should also like to welcome Professor Guru, who has been very, very supportive of the initiative in organizing this particular program. Professor Hanuman of the Department of Computer Science, University of Mysore, and Professor Harinarayana, Chairperson of the Department of Library and Information Science. Professor Shalini Ars. It was Professor Shalini Ars who first wrote to me that Dr. Baeza-Yates is coming to India, then we organize a program. And it's largely due to her efforts that we have been able to it's largely due to Professor Shalini's efforts that we have been able to get Professor Bates here. And I should like to specially welcome Professor. She also happens to be a trustee of the Sarada Ranganathan Endowment for Library Science. I also would like to extend a very warm welcome to Professor Kavi Mahesh, who is a trustee of the Sarada Ranganathan Endowment, a former director of the Indian Institute of Information Technology, Harvard, first director, founder director of the Indian Institute of Information Technology at Harvard. Mr. Satyanarayana of Informatics India, Chairman and Managing Director of Informatics India, also a trustee. Professor Asumbi is here, and many other distinguished professors, faculty members, students are here. I welcome all of you. I welcome also members of the media, distinguished teachers, and research scholars and students. Welcome again to everyone.
Thank you, sir, for your warm and thoughtful words of welcome. And I invite Professor K.S. Raghavan to this endowment lecture. It is now my pleasure to invite Dr. Shalini R. Aris, former professor, Department of Studies in Library and Information Science, University of Mysore, to introduce our distinguished speaker for today's endowment lecture, Dr. Ricardo Baeza-Yates.
Good morning, friends. I would like to add my own welcome to each one of you for making time and efforts to come to this lecture. So my special personal as well as on behalf of all the organizers, that is all the units of the organization, Department of Computer Science, Department of Library Information Science, as well as the Sarada Ranganathan Endowment for Library Science, because I feel I am part of all the three, including part of the University of Mysore. And also I would like to extend a special welcome, of course, Professor Bhavan welcome each one of you, and also individually. I would like to extend a special welcome to Professor Veliappa, Professor Literature, English Literature here, and also former Vice Chancellor, who has come here on behalf of, I would say, my invitation to our own group. We have another group where we are all members. And also to Ricardo's friend, dear friend, Christina, who I would say is the main reason that this whole thing came together. I mean, with this a little bit of I would say note of welcome. Now my pleasant duty is to introduce our dear friend Professor Ricardo Baeza-Yates to the audience. How does one introduce a celebrity? It's because he's a celebrity in the field of information retrieval, AI, because he's traveling around the world talking about recently, of course, focusing on responsible AI. Before that, web search, because he's one of the, I would say, his contribution is foundational to the field of web search. Anyway, let me begin with the formal introduction of our guest. He is currently a WASP professor, as you have seen, in KTH, Sweden. But more importantly, I would say his contribution to the field is so phenomenal. He is also a fellow of ACM as well as IEEE. Ricardo began his, I would say, research career by getting a PhD from the University of Waterloo, Canada. And since then, he has occupied very important positions both in the academia as well as in the industry. He was a professor at University of Chile for about 20 years, where he also founded and directed the Center for Web Research. So that was his foundational, I would say, institutional work in addition to research work for the field of web research. He was the VP for research at Yahoo Labs, both in Europe as well as in Latin America. And later, he was the Chief Technology Officer for Intent, a semantic search company, till recently, that is till 2020. And after that, he served as the Distinguished Professor and Director of the Institute for Experiential AI at Northeastern University, Boston, as well as Silicon Valley. Till recently, he was for about 5 years, I think, he served as the Director of AI there, Experiential AI there. And he continues to his work as professor at currently, I would say, 3 distinguished universities, including the University of Chile as well as Universidad Barcelona, and including the University of Northeastern University. Well, given his immense contributions, he has been recognized with many honors. I'm not here to catalog all of them, just a few I'm going to mention. One is he is the ACM SKG Award for Semantic Graphs in the year 2022. As I already mentioned, he is a fellow of ACM as well as IEEE. And his book, for which he is world, I would say, recognized as well as known, that is Modern Information Retrieval, which he wrote, and which has seen the second edition and is going to see the third edition as well, which won the award for the best book from the ACSMT, that is Association for Information Science and Technology. And he has an edge index of more than 90. That gives you an idea of his research contribution. And he is currently involved with many startups. He's founded or co-founded many startups and continues to be a mentor, research mentor for many of these companies. As I said earlier, his current focus of interest is responsible AI, and he is the ACM Distinguished Speaker Program. There is a distinguished speaker for ACM. So he travels around the world talking about many of these interesting topics. If you go and check it out, you will find that there are many areas which I chose for this is the semantic research. Many areas in which he is be speaking around the world. So I call him the traveling academician. Maybe something like, you might have heard of some of it. Right? So traveling around, co-authoring or collaborating with many. So that is Ricardo Baeza-Yates for you, a distinguished scholar, researcher, and more than anything else, a dear friend. So with this introduction, I would like to just end with my own. Of course, one other thing I must add. I had forgotten, but I must remember to mention. One of his recent accolades is he has been given the honorary doctorate by the University of Gothenburg in Sweden. That is his latest. Just I think 1 month back. So he got the honorary doctorate from Gothenburg University in Sweden. And then let me also end with my own self-promotion or commercial, so you can call it as. Well, I did my podcast series, I think, way back in 2022. And if you want to check out more of what he talks about responsible AI, this was just before, I remember, just before the release of ChatGPT. So we were talking about the potential and pitfalls of language models at that time. So you can check it out. So with this brief introduction, I would not like to stand before you and our dear speaker. Over to you, Ricardo.
So thank you, Professor Bhavan. Thank you, Shalini, dear friend. Thank you for all you to come. I hope you understand my non-Indian accent. And my real, I think Shalini talked about me liking to travel is really because I love maps and I love geography. I love to know new places. So I have been many times in India, but this is my first time in with Mysore. So thank you for such a great welcome. And today I will talk about not only semantic search, but I want to talk a little bit about what is happening with generative AI, because I think that will have a big impact on us as a society and a species. So this is thanks to the ACM Distinguished Speaker Program, as Charina mentioned. ACM is the largest association of computing professionals in the world, more than 100,000 professionals. Although it started in the US, now more than 50% of the members are outside the US. So who is an ACM member here? No? Okay. You can have a student chapter, and that will be the first step. I was a student member a long time ago, last century. So you can go to acm.org, find more information, and as also you mentioned, I'm a proud ACM fellow of this society. So this is what I want to cover. First, I will talk about semantic search. Then I will talk about neural AI, which is the new way to do search using the power of basically deep learning. And then I will talk about the risk of generative AI, because that is part of neural AI, and predictive search. Because how many people is using ChatGPT for searching? Tell the truth. Okay, you see, I need to talk about this because ChatGPT is not a search engine. So that's the problem. Okay. So let's start with the classical semantic search. Let's say before 2020, before ChatGPT 3.5. Basically, you need 4 elements. You need an ontology, you need a lexicon, like a dictionary, you need a dictionary of entities. Basically, entities are names, people, institutions, dates, places, any proper name is here. And then you need some linguistic rules that will help you to understand language. So that's part of what is called natural language processing. Now, in many cases, it's language dependent. So it depends on the language, and you will notice there that ontology could be language independent, but of course the vocabulary is language dependent. For example, India has 22 official languages, so that makes it much harder to have a good search engine in all these languages. And the entities are normally language independent, but sometimes it's not. For example, Mysore in English, Mysuru in Hindi. It's a different way to mention the same place. And here I would like to do a small detour because many people don't know these things. We have about 7,000 languages alive, about 600 are here in India. So India has almost 10% of these languages. Only around 300 have a Wikipedia, so that's less than 5%. Only about 200 are supported by generative AI, not too many. And for example, if you do the exercise, I did it, about 10% of the world don't speak these languages. Sorry, cannot use generative AI because they speak these languages. Now, if you take the people that don't have access to internet, about 35%, then you take all the young people, you take the very old people that will not be digitally savvy. If you do this union of these numbers carefully to count for the overlaps, you will get that 55% of the people cannot use generative AI. So we are on the privileged side, the 45% that can use it. So please don't say we're democratizing AI, we're just increasing the digital divide. Some people call it about the AI divide. That divides the people that can use generative AI with the people that cannot use it. And I think that's very important to have in mind because we need to close that divide that's growing faster than any other time the digital divide grew. Now, what is the lexicon? Well, the lexicon is like a dictionary. And here you have an example of an animal, the cheetah. And here you see, for example, 3 different ways to write cheetah in 3 different languages. That's the fastest animal on Earth. And you can imagine the problem here is to have this complete for every language that you want to use. Now, the entity dictionary is mainly, as I said, language independent, but depends on the case. For example, you have Lady Gaga. Lady Gaga is Lady Gaga everywhere, right? But for example, here I have the example of Genève. Genève is Genève in English, but it's Ginebra in Spanish, and it's Genf in German, and so on. So you have at least many different ways to say the city in many different languages. That happens a lot with all cities that are in Europe. And then we have linguistic rules. There are many kinds. There are semantic representations, there are case frames that helps us to know the context of whatever you are saying. So I will not go into detail because I don't think you will be able to read, but basically this is expressed in a kind of a XML language, a structured language to the described text. And then finally we get to the semantic engine. If we have all these components, we can do the semantic engine. So we have basically a combination of the ontology, the lexicon, and the entities, and from this we can capture concepts that can be understood by the semantic engine. So the semantic engine will be like a search engine, like one search engine that they use, but enhanced with all these concepts and all this knowledge. Some people call what is in the right a knowledge base. So this is a very well organized knowledge base. Sometimes knowledge base is also called a graph, knowledge graph, the same, organized knowledge, and can take many different representations, but basically it's composed by all these things, ontologies, lexicon, entities. Now, what the semantic engine should do, and these are the important things, the functions that you need to have. So language detection, today you can do it with a language model, so you can guess what is the language of these 200 languages that are supported. Then you need to remove everything that is not interesting for the semantic engine. That's called boilerplate detection and removal. I will give you an example later if you have never seen the word boilerplate in this context. Then you need to tokenize and lemmatize. There are some places where you can see how, for example, language models tokenize things, and it's not what we think, because we think that it's just words, but sometimes words are split. So if words are split, really they're not capturing any semantic meaning. They are capturing just statistics, and that's part of the problem. Then you can do part of speech tagging, morphological analysis. These are part of natural language processing, and then you extract the entities. All these entities like names, places, dates that you want to have in your system. And then you need to identify concepts. For example, Karnataka will be a concept, a state in India. And it's important, that's much more than a name. And this is important because, for example, when you have an AI system that translates an image of a cat to the word cat, it's just a representation change. The system doesn't understand what is a cat, like we do. And then we can do the final task, which is to retrieve documents, to rank them, and sometimes to classify them. These are all the tasks that you want to have. Well, how you can do this? Well, you can use classical NLP. This was the first way that people did it in the 90s, and then even in the beginning of the century. But then we need to go to statistical NLP, and this is using, for example, embeddings. Then you don't need to use words, you can use encodings for those words. And finally, the last way to do this today is language models. I assume you all know that these are technology behind chatbots and other generative AI tools. Now, let me give you an example of all this. For example, this is a web page. Then, for example, this is the boilerplate detection. So you want to remove everything that is not interesting. For example, in this case, we're saying advertising is not interesting, it's not part of the content. That's not always true. Sometimes the answer is the advertising. And for example, here we need to process all this text and images. It will be multimodal. And for example, we need to find that here you have several entities. For example, one is a basketball team called State Warriors. also there is a game 1, this will be an entity here, and also, for example, that this is a game of the Western Conference Times. So here, for example, this is a small sentence, you have already 3 entities, so it's not easy to find all the entities. Now, how do you do this? Well, I mentioned already what is this: people, places, organization, brands, works of art, and so on. And most of the time they will be represented in ontology, so it will be very easy to detect them. But sometimes they are not in ontology and you want to detect them anyway. So there are some patterns, like, for example, using uppercases that helps people to find new entities or unknown entities, and in that way you can grow the ontology and the lexicon. So these are the ones that are not in the dictionary, and you can infer people, places, organizations. Sometimes the entities are implicit, they are reference to entities, also you want to detect that, and so on. And then there are other entity types that you can try to get, like phones, money, date and time, and so on. Typically, those are using regular expressions or other statistical patterns to find them. They're very good name entity recognition systems using AI, not necessarily deep learning, but other techniques that you can find more than 90% of all entities in text. Of course, that depends on the language. This is language independent. And now you can try to identify document characteristics. So these are possibilities. You can try to find the topic, some aspect around the topic, the type of topic, the genre of the document, identify problems like spam, adult content, offensive content, using arms, gambling, and so on. So anything that you think could be dangerous or could be harmful. Then also you can try to measure quality, reliability, so on. There are many measures for that, because also they will give you an idea of how relevant might be the text, because if it's well written, probably it's more relevant than the text that's not well written. And finally, we can have other things like it's a web page, you have mistakes, it's a shopping cart, and so on. So there are other things there. But is this enough? Well, let me give you an example. Let's say a friend is in New York and says, what about lunch in Times Square at noon? And basically, you take the 3 entities there. So lunch is about some time, Times Square, and noon. However, this is not enough, because you can get the same representation for something like, I was in Times Square before noon for lunch, or don't go south of Times Square after noon for lunch. And that's still the same. So this is the ambiguity of our language, and this is why it's so hard. We need to know the context to get the right understanding. And that's why chatbots do silly mistakes, because they don't understand the context. They don't have what is called a word model. It's a model that is based on our sensors. We have 5 senses, and we can not only read, but we can feel things, and we can see things, and we can smell things, and we can taste things, especially in India. You do a lot of research on these things. And then you can do syntactic analysis. For example, let's say I bought a watch at the store on Monday. Then, for example, you have an event. I bought something. You have a role. I'm a person. You have an object. It's a watch. You have a location. It's the store. Maybe from the context, I know which store it is, or at least where is the store, which city. Now, if I'm in Mysore, I will assume that the store is in Mysore, and I did it in Monday. So then we're going to do a semantic reduction. So basically, if you have lunch in Times Square at noon, you want to basically have the same for all these variants that you can have. And this is just a few. There are so many ways to say the same. And this could go on, and you can say it longer, you can take more time, you can put other things in between, and still the final message is the same. You can be very direct, or you can be very slow. So you can reduce this to a single language-independent formal interpretation. And this is important because then you can translate it to another language in the answer. You can do this. Now, one application is what we call, and when I was at Intent, and Chalini mentioned I was CTO of this company, having expert answers. So expert answers are some data sources that can answer specific queries in a specific context. So for example, you do this, you have the interpreter, you get the formal interpretation, so the standard semantic representation, and then you want to answer that through an expert. What kind of experts? Well, there are many experts. For example, Yelp will be the typical expert for local business listing. Find the restaurant. Or you can have Aku Weather to get the weather if the question is about the weather. It's amazing, but for example, in the US, about 5% of the queries are about the weather. People is worried about the weather, even though sometimes the prediction is wrong. Start.com is, for example, expert source for sports data. There are many queries in the US about baseball. Here will be cricket. American football. Here will be football or soccer for them, whatever, and so on. And then you can have in-house experts. For example, one that finds entities and uses the ontology to answer them, and so on. And there are many flavors. For example, some of them may be in-house, some will be data that you have, but is provided from third parties, so you acquire data to answer these questions. And one would be to use another service, external service, to answer this. For example, in this case, Apple Weather would be an external API. And this is what it looks in practice. These are real numbers from a search engine. And for example, these are all the queries that are answered by experts. The top line in red, so you see that 40% of the queries just were answered by experts. So you don't need to do anything else. The top one is business, so local listings, the one in blue. The one in dark is images. And as I said before, the one in red here is like 3%, that's why. So with expert, you can answer many of the queries. And then to finish this part, you need to have this. This is the most interesting part research-wise, a query understanding workflow. I don't think I have a pointer here. So,
No.
okay, yes. So you start with the user. The user has a need. The user has a context. And this is the most difficult part to guess because it's inside the brain of the user. And sometimes all the context, for example, is translated to a single word, bond. All right. What bond she's thinking on, we don't know. But for example, you can apply query completion, so you can help how to get to the query, and this is standard now in search engines. Yahoo was the first search engine that had this query completion. Then you do a spelling correction. In this case, there's no need to. You do semantic analysis. Then you can suggest queries. For example, you suggest that could be James Bond, chemistry bond, or for example, investment bond. And then you try to do intention analysis. And here you need to use AI. Say, for example, this is an information query, and it's about information of a bond. Or this is a transactional query. For example, the person wants to buy a bond. So this is like 30%. So this is a prediction of what type of interaction the person wants to do. And then we get to the last part, which is the intention ranking, because you need to know what is the most probable case. So here the most probable case is that he is looking for a James Bond movie, or for example, could be also about TV. And then you have other things like, for example, Bond Street in London, the chemical bond, and so on. So this is the final ranked result that has a diversity because we cannot know the context, because the context was not given, and it's very hard to get it. But for example, if this person is in London, maybe Bond Street has higher probability because it's in London. If this person we know that talks about a lot of financial things, about queries about finance, maybe he wants to buy a bond and so on. So also the context will be given by the user and the place of the user and past queries, and we can get a better prediction of what we want. So But today we can use neural networks and we can be much more powerful. So the neural IR, which is called, because of this use of neural networks, like deep learning, the basic idea is very simple. You generate a representation for words based in embeddings, vector embeddings. And for that, you just take a huge amount of text, you understand the context of these words, and then you generate representations such that words that are used in a similar way will get very similar representations. So synonyms will be very close to in this vector space, and this is one of the advantages because we don't need to take care about synonyms. The same, all the conjugations of a verb will get close, and you will get this. So, for example, this was invented by Google at the beginning for words, but then was extended for sentences and other objects, multimodal. And here, the first one, the word to get, the classical one, but things like globe, verb, cast text, and there are many, many more that you can use, and they're free. So you can use this space of embeddings for any application you want to do for search. And then you need to build a vector database, which is not the same as we used before, that was an inverted index. And basically, vector entries will represent words, sentences, paragraphs, and documents. And now searching is a similarity search. Find things that are close in this vector space. Now, this vector space is very large. Typically, they use at least 300 dimensions. But in some cases, if you have too much text, you use more, 500 dimensions. So they're very large space objects. And then there are many problems you have to solve. For example, how to aggregate words, vectors of many words. You take the average, you do some weighting, and so on. Quick similarity function. The most used is the cosine distance, because these are vectors. And then you need to do very good approximate nearest neighbor algorithms. And this is not an easy problem. For example, if I give you a huge index of this thing, the main problem is where to start. If you start very close, you're lucky and you find it very fast. If you go very far, you need to wander in this space a long time until you find it. This is like saying, I want to find a story in Mysore, and I put you in the palace of Mysore. Or the other possibility, I put you in Bangalore. Well, you will take more time, right? And then this is the typical usage for what is called today retrieval augmented generation, which is a combination of generative AI, and I will explain this in a few slides, and standard search. And there are many examples here of vector database. Now, this is the interaction. And this is from a book that I published this year. This is one of the co-authors of the book. I would mention that at the end, but it's a complement to my book on how neural AI works. So you retrieve some candidates, for example, using a standard techniques from information retrieval, and then you use a neural reranker that will improve the relevance order that you get from here. And this is coming from these learned query document representations. There's something called learning to rank that helps here, and then you get the final result. So this is the key part, how to using AI to do a re-rank of the results. You can have also a dense retrieval system. So dense retrieval system works a little bit differently. You have an index of document embeddings. So you don't do this in the workspace, you do it in the vector space. This is more interesting, although the search there will be more complicated. And then you use this learned query representation encoders with a neural ranker to get the result list. So this is the most used today. And to do RAG, well, this is the difference between the standard RAG workflow and how it's today. And so basically, you give a lot of documents, sometimes pre-stored, sometimes even online, to the system, and the system, the generative system uses these documents to answer the question. So in that way, you have a closer domain. And for example, less hallucinations because you know the domain. very well. And here you have to do things like enhancing the answer, customizing, and so on, but it's still the same thing. You do re-ranking, filter, and so on. This is from a survey that you can find from one last year. So this is the typical RAG architecture, and this is from the same book I will mention at the end. So basically you have embedded index again, but here you have the top K documents, and instead of giving directly the answer, you have a generative AI model here, the decoder model, that will give the result. So basically you have a language model at the end to answer the final result based on the results of the neural AI system. So this is the retrieval part, and this is the generator part. That's why it's called RAG. And there are many models, but we'll skip this because I want to talk about other things. So what are the dangers of generative AI? And you will understand this because people is using this as search. So I hope you can read the cartoon. Yes? The one in the back. So is the parrot smart? How many people here think that the parrot is smart? Only me. Okay. The parrot is an animal. Even learn to speak. Why the parrot will not be smart? Right? But I put this joke to show how easy it is to imitate intelligence. Because really we don't know, because from the answer, he's saying that it's not smart, but from the answer it looks like it's very smart. And we don't know, because both possibilities are valid. So this is what I learned the last 3 years. It's so easy to imitate us, and that's the problem. So we're not that special. Yeah, parrots can speak too. Right? So this is like, for me, like a Pandora box. You know, the Greek mythology, and then someone opened the Pandora box, and then everything, all bad things went out, and the hope was at the end there, still in the box. I hope is still there. But a few years ago, we liberated a new one, procrastination, with social networks. And now we have countries like Australia that are forbidden teenagers to have social networks. Anyone less than 16 years old can't have it. In France, they're forbidding to bring cell phones to the classroom because otherwise they get distracted. Very good idea. And so on. Technology is not always good, especially if you use it too much. But now we have another problem. Generative AI is getting laziness out. Humans are lazy. And we all have been students. I was lazy too. I'm lazy today. If I try to avoid doing something, I do it. But the problem with laziness is that brings mediocrity, because you will do things as good as a language model, but not as good as you can do it. And the problem is that how good you can do it is not how good you can do it today. It's the best you can do it with the potential you have, but you will never develop that potential if you don't do it. So you need to do things. You need to waste time on learning and be better. So this is very important for students. For chatbots, they are very fluent, they are confident, they are naive because they believe anything I will say. So I can lie to them, and the answer will be typically, I'm sorry, I'm wrong, or don't lie. I apologize, let's try again. They're incoherent, because not all of the time they make sense. And finally, if they really hallucinate, they're bad. Right? I hate the word hallucination because that was a marketing thing to basically avoid to say, I make mistakes. Now, would you have a friend with these characteristics? I wouldn't. But today there are millions of people that are interacting with chatbots like they are digital friends. And this is very dangerous. Because it's really great to have a friend that never disagrees with you, right? Always apologizes. Yeah, it's very easy, but you don't get any social skills by using that. And then you have other problems: bias, hate, especially bias, censorship. Everything you will never see. For example, things that are very complicated in the US, like gun control or other problems. Lack of diversity. We already talked about languages. Do we want to have only 200 languages in the world of all this diversity of 7,000 languages? Many of them in India that may disappear. Cultural colonization is the most, really the most complicated thing. So, Raghavan, how many continents there are in the world? 7. So you are colonized. You have been colonized. How many circles are in the Olympic flag? Anyone remembers the Olympic flag? How many circles? 5. And one continent is not there because it never participates, the Antarctic. So the traditional Western culture number of continents was 6. Columbus rediscovered America, but there was only 1. For the US is 2. They don't want to be with South America. So if you say 7, you are being colonized, but you don't notice. And there are more subtle things that are happening with the colonization. Continents is just a small. And then we're losing skills. So how many people can find a place in Bangalore without a GPS? Bangalore is a very complicated city also. No one. Some people cannot even read maps. We learned how to go back to the cave at night without the moon for many, many, many years. We learned that. Today, if you put a person at that, will never go anywhere because that's enough where to go. So we are losing, for example, our orientation skills, and in the future we are losing our thinking skills because to think we need to write. Writing is the most complicated way of thinking because we need to communicate something to someone that's not in front of us. So please think, and that means write. And then we get to more complicated things that never happen, right? Sadly. This is my best example of how well you can fake things. This was a meeting that happened last year in Hong Kong, a video conference. A Hong Kong employee with his boss in the US and many other people in the meeting. After the meeting, he understood that he had to transfer $25 million to another company, and he did. To find out later that everyone in the meeting was fake. The videos, the voices, maybe he saw something and he said, oh, internet problem, right? But he was defeated by this fake video. We have problems with copyrights, very important. We have very important cases that are still going on after more than a year. The New York Times and Daily News against OpenAI and Microsoft, Getty Images against Stability AI, and there are more in Canada, in the UK, and the result of these cases will change things for generative AI. Although already some cases for Llama, the language model of Meta, the judge said that those were fair use. So it was okay to use public web pages, even copyrighted, to do But it's more than that. It's not only copyright. In the case of New York Times, they found complete accuracy in the answers without even the right credit. Because this system can memorize things. So you can memorize when you have 1 trillion parameters. Almost like memory. Especially if it's the only article that talks about that. And then we get to mental health, which is really sad today. The first case happened in Belgium in 23. A PhD student that had wife and 2 kids, after 6 weeks interacting with a chatbot, decided to kill himself. So he had a mental health issue, but it's different if you talk to a professional, right? And I want you to read, I hope you can read it. You can read it, right? This was the last conversation that the wife found. Black is the person, red is the chatbot. Please read it. this is like taking from a science fiction movie, right? If you read the end, implicitly, the chatbot will meet the person in the afterlife. You can believe in afterlife, that's fine, but I don't think you will meet a chatbot there, right? And you can decide also if the chatbot help or not this person to commit suicide. This is a personal call, so you can decide. I thought that this was the first. Well, I was wrong. Last year we had 2. This year we have already more than 10. And these are the ones that we know. These are the ones that we get to the news. Probably there are many more and we don't know. Especially because it's not easy to connect the chatbot with the person if no one finds the conversations. Sorry, not the conversations, the interactions. Because to have a conversation, you need to understand the system don't understand. So for example, in this case, a Canadian woman interacting with Harry. Harry is a between quotes, a therapist, using ChatGPT. Of course, it's illegal therapist, doesn't have a license, and didn't work for her. Or this case on the top, a person in the UK, a veteran, that the chatbot, I don't know if you can read, told him that his mother was complotting against him. And of course, he couldn't take it, that the mother was trying to harm him, and he committed suicide. And the most complicated case, last August, Adam, a teenager, 16-year-old, in the interaction, the word suicide was used more than 1,000 times. The chatbot used 6 times more times the word. So the chatbot used the word much more often. And the system sent 300 warnings to OpenAI, and there was no human in the loop. No one did anything. After this case, because they have a case, and they just published their deposition. So like 2 days ago, OpenAI said I'm not guilty because this was a bad use of the tool by the teenager. But he's a teenager. Well, after this case, they put parental controls. They should have been there before. And then we could avoid having a teenager dead. So this is the problem. You need to do things right, minimal things like putting parental controls. Generative AI is like a powerful gun. You can get so much information that is wrong that you should keep it locked. It's like a gun at home. You lock it, so your children don't take it. If you are silly enough to have a gun. In the US, a lot of people have it. But you cannot leave this to any people to use it. So this case will be complicated for OpenAI because the problem for me is not the bad usage. The problem for me is 300 warnings and you didn't do anything. That's a problem. So recently, like 1 month ago, OpenAI published an analysis of how many people are using ChatGPT for this kind of interactions, and it's about 1 million people. So I don't understand what they're waiting for. It's 1 million people talking about mental health issues. That's a lot of people. They need to do something. And let me give you some examples, because this is personal for me. So in February 2023 in Brazil, someone asked, give me famous Brazilian researchers that have died in the last 20 years. I'm there. And the system says, although I'm Chilean, I have lived and worked in Brazil many, many years. I have never lived and worked in Brazil. Okay. So this is what they call hallucination. For me, it's just a BS. Yeah? But the truth, the chatbot is right. I'm a robot. They are very good robots, so no one notices. Now, of course, I wanted to know why I died. So I checked my biography, and all these things are wrong. So even says, how do you know this? Okay, there's some reports. And the answer is pretty possible. That, for example, ACM will will report on my desk. I don't know. I hope that doesn't happen soon. But why? Well, there was a person called Ricardo that died in Texas, but in the different year, 2021, COVID. So maybe that's why the system predicts that. It's a prediction. Of course, the prediction is wrong. So these are predictions. More specific, what you are asking, more probable is that they make a mistake. So for very generic things, you can use, let's say, the chatbot. But for very specific things, don't use it. Now, why I use my biography as an example? Because if you read this, you will believe it. And there is only one person on earth that can fact check this right away. Me. Nobody else. No, my family, my colleagues, no one knows all of what I've done. And you can fact check it, that you may lose like half an hour to check every fact or more. And of course, you're lazy, so you will not do it. You will believe it. This is the problem. And I will talk about this later. And by the way, if I ask in Portuguese, it's not cancer, it's leukemia. So, but the year has changed. Now it's not 2022, it's 2021. And if my birthday is correct, it doesn't know any math, because from 61 to 21, there are not 55 years. So this is also not. So when ChatGPT 4 appeared, I checked if things change. And oh, there are more hallucinations, more than before. However, there was a prediction that I had won an award in Chile that I won last year, the National Applied Science Award. So if you are over 50, check what ChatGPT says. And if you have an award that you haven't won, please apply to it, because otherwise you will never win it. So you can do this. And I didn't apply to this one, someone else put my name, but it was a good prediction, so I should check what it says now. But more wrong things. So more false facts, but I was alive again. So I don't care. I'm more famous. Well, why not? So very important to finish this part and to get to the last part of predictive search. I found a replica of this outside the IIIT in Bangalore. I don't know if you have seen it. They have a thinker like Rodan. So this is imitation of thinking. Of course, not thinking. So please don't use this. And this is what is important. They don't read, write, or see. They don't understand anything. They don't reason, but they do amazing guesses, predictions. They don't think. They imitate conversation. They don't lie because they don't have a database behind. So they don't know what's true or false. It's just a prediction that is right most of the time. Don't have intentions, or in the future it may happen that they can have intentions if you program them that way. And finally, they don't hallucinate, they make errors. So very important, you need to be human, very human, because powerful limitations create powerful illusions. And you have famous people believing these illusions. Even great computer scientists believing that these things are intelligent. Now, predictive search. So you are using it to search. What's wrong? Should we use LLMs as search engines? Well, if you ask Chirag Shah and Emily Bender, they will say no. Why? Why not? Well, because possible answers are not always relevant answers. If it works 95% of the time, and we don't know exactly how much it works, because all benchmarks are limited. There are exponentially many ways to ask the same thing. So all benchmarks are really fooling us. We are fooling ourselves by these benchmarks. So we don't know what is the percentage. But if you do that, people will believe it 100% of the time. And this is the problem. Even if it's 99% of times correct, this 1% could be very dangerous. Do you know what's the difference between a chimpanzee and a human in the DNA? 1.1%. And they're very different. They're a bit more aggressive than us. We have still many words. They don't talk, but they're very good at some tasks, better than us, but they're different. So 1% would be a big difference. Some people think that 1% is small. No, 1% could be very large. Depends on what is there. Also very important, you cut the user's ability to do the sense making that is critical to information literacy. You need to do critical thinking. And if you don't do this, you are losing the one way to learn how to do critical thinking. And here it's a list of things that sense making includes, like refining the question, understanding how different sources speak to the question, and locating each source within the information landscape. But you can use it for other things. You can summarize documents. You can translate documents to other 200 languages. You can expand queries. You can do many things that are safe, that don't really messing up your learning process. Let me give you an example. I tried this, I had it with the US before, 2024, it was really bad. I said, let's try this. So I did this last night. Give me a map with the states of India. Okay? And first, I got this. So instead of Punjab, here it says Punjabi. Instead of Jammu and Kashmir, it says Jammu. I did learn this yesterday. I know this because I love geography. Okay? There's a state missing there. Now it's part of Myanmar. This is not the state, I don't know. It's very hard to read this. This one, this part of India is part of West Bengal, but it doesn't have the same color, right? And here there's a boundary missing. So doesn't know how to draw a map. The rest of the names are okay. But then I said, I want the same map, but with all the names. I'm forcing to put all the names. This is what I got. It was really silly. For example, Nagaland appeared twice. And of course, I wanted the names in the map, not below here. But he's kind of smart in this sense. Oh, I don't know where to put the name, I will put below. Like the student. And this is really worrisome. This is Magaland. Maybe it belongs to Trump now. So I will be worried. Maybe Trump is taking part of it. So this is a comparison between what you can do with a real search engine, descriptive search engine, and genetic one. And this is for the great work of Shah and Bender. So, for example, the difference between relevance, novelty, interactivity, speed, personalization, and transparency. You see that they are all different. So they have different advantages and disadvantages. So we need to be very careful because generative AI is not the search engine. And here I have a very interesting example I got last year. I got it from a friend, that has his computer in English. And he asked the question in English. Okay, this is Gemini. And he asked what it meant in allusion to. So I guess you know what is this in allusion to means to mention something without directly identifying it. But look at the example. The example is, for example, you might allude to a cab sitting behind you to stop your friend from discussing plans to rob a bank. So this is stereotype Chileans are robbers. I tried this in the US, and of course, the example was completely different. It was completely safe. So I think personalization, contextualization is doing a really bad job here, and it's doing a very dangerous job. I reported this to Google, I hope they did something. So the question is, for example, other people are saying, okay, we can't use it to search, but can we use them as relevancy judges? Try to see which documents better than others. And here's an interesting diagram that I found recently from a paper that shows the difference between a human judgment and an LLM judgment. So why they're different, like the previous table we saw. Well, many experiments have shown that they are aligned, so you can use it partially, but there are many issues. For example, they are more obedient than humans. They are not reliable as a tool because they are too different. You can manipulate them. Cannot discern subtle but significant difference. So in general, they work, but for difficult cases they don't. And this is very interesting. This is very recent work this year. They are biased towards LLM-based rankers. So in some sense, they recognize themselves. So if you did the rank, I will give you a better mark. And also, one paper showed that there was a bias towards LLM-generated text, but this is not corroborated completely yet. But this is really worrisome, because that means that genetic answers will have better ranking than human answers. And that's not what we want, right? We want the opposite. Unless the human answer is really bad, but in general, if you are an expert, you should do it. So before ending, remember the limitations that we have in machine learning, and this is a little bit of responsible AI. Limitations like you cannot learn what's not in the data, you cannot learn what you do not know. Remember, data is a proxy, data doesn't represent all the context. Don't define the word, please. For some human programs, like hiring a person, giving a scholarship, giving justice, data is a very bad proxy of reality. What matters is not only words, so we shouldn't be measuring accuracy. Imagine that only we care about when it works and not what happens when it doesn't work, like medicine, like food, like transportation, like everything else in the world. Because if you assume that you care about only when it works, all errors are equally likely and have the same impact, which is never true. For example, self-driving cars, some mistakes kill people. Or like in LLMs, some mistakes help people to commit suicide. So, very important, if the system is not sure, say I don't know. But sadly, I've been told that ChatGPT says that I don't know, sometimes 5.0, but haven't seen it. So this is what happened in Arizona, for example, when a self-driving car of Uber killed a woman that crossed in a bicycle at night in the wrong place. That was not in the training day. And the backup driver inside was not attentive, so the woman died. And there are many more examples from self-driving cars. So to end, we need to evolve neural IR to include knowledge, to include real logic reasoning, and to include common sense. And this is why human errors are different from AI errors. So this example here is what I call a non-human error. All people will recognize the woman in a bicycle. And why it's dangerous? Because we don't have common sense for it. So this woman, and I can apply very well to it, this is what we do every day. We see a car coming, we know we don't have time, but we cross anyway. Why? Because we assume that the human inside will not kill you, right? But this car didn't slow down, kept going because thought that was a different kind of object. So our common sense doesn't help with AI errors that are not human. Second, search engine should avoid promoting user laziness. How we can change search engines in a way that promote critical thinking? That's an open problem. And finally, and this is what I try to do today, you should learn about the danger of humanizing technology, of creating that something is intelligent. The first chatbot was in 1956 in MIT by Weizmann, was called Eliza. When Weizmann saw how Eliza was influencing people, for example, his assistant, he was really worried. And 30 years ago, he said something very important. We shouldn't never confuse computer with humans. That was 30 years ago. And this was the first time an AI person was against AI. But for the right reasons, not like Geoff Hinton that is talking about maternal instinct and other silly things, and Terminator. That is something that will never happen, probably. So please remember this part about being lucid, being human. So I'm not worried about artificial intelligence, I'm worried about us. Can we be smart? And this is what I said about Joseph Weizmann. never confuse computers with humans. So I will do also some self-advertising as Fellini. So this is not the original of my book, but I published another one in 2015, and this year I published a complement to my book. It's called Information Retrieval, Advanced Topics and Techniques, and includes everything that was not known in 2010. Things like knowledge discovery, things like neural AI, and privacy, and many other things. Thank you.
Take some questions.
Yes, please. I will take some questions.
Thank you. That was truly wonderful. My question is, for the last several decades, we have been trying to build knowledge resources like Lexica, SRI, and ontologies, and so on, with limited success. Despite all these problems and dangers, do you think AI can help us build a very comprehensive knowledge resource?
That's a very good question. I think the answer is yes, can help. I always think that we should build all these things based on usage, not based on completeness, because completeness is impossible, right? But for example, I have some work where I show that with 1% of the web content, you can answer like 25% of the queries. So these are power-based. So basically, with very few resources, you can answer many, many queries. So if you do this, AI can help to do this, to say, what is the best knowledge base to answer, let's say, 90% of the queries? And the AI will do a very good work with that. The problem is that still will have a lot of problems inside, like bias. Bias will be the main problem. So like cultural colonization will be a second problem. So all the problems I have mentioned will be there in that corpus. Sorry, in that ontology. And this is the problem. And will be so large that we'll not be able to check it because we're humans. So this is one difference between neural networks and humans, that are so large that we know how to construct them, but we don't really understand how they work, in the sense that we cannot imagine the result. Last year I saw, I was in a Q&A that Don Knuth is Turing Award, emeritus professor from Stanford, the father of algorithms. And he said something that was really interesting the way he said. He said, I hate the idea of using algorithms that we don't understand. And this is part of the problem today. These are black boxes not only for people, they're black boxes even for us. Because we know how to construct the black box, but if someone said, okay, what will be the output? No idea, because it's too complicated. 1 trillion parameters, who knows how the math goes. So we're capable of doing things that we are not able to interpret. And this is part of the problem. We are playing God, but we are being blind at the same time. So maybe we need to do it in a very careful fashion, like close domains, and be able to check it. We need to have a human, not in the loop, on the loop. So. Charlie, good gender parity. Great.
See, in the beginning, AI was focused on logic reasoning based, right? Somewhere along the way in the 90s or a little later, with all this big data, it shifted focus from logic based or logic reasoning to data. So, do you think that shift is causing all these problems, or is there any way to now we can go back to building the logic reasoning into that data?
Yeah, I don't think all the trouble comes from only looking at data. I think the trouble comes from us. So as I said, we are the problem. We are, for example, that would be like my talk yesterday. We are obsessed with big data, but very few companies in the world have big data. Why we are working on big data? Why we want to scale big tech? We should work on small data. Most problems in the world have small data, in medicine, in business here, and so on. So I think we need to learn from the mistakes we did in the last, let's say, 20 years, and try to do hybrid things. That's why at the end I say that we need to combine these things, knowledge, logic, reason, common sense, with the current technology. So we need to take the best from the past and the best from the present to build a better future. Yes.
It was very interesting to know that even if billions of parameters have been used to train the large language models, still there is an error. So according to you, what will be the strategy to effectively train the large language model so that we can expect better results even in case of biases? Is there any strategy to avoid the biases as such? Because data is the whole thing to train the model. Is there any pre-processing technique you can apply where we can avoid the biases and then we can do the better testing of the model?
Yeah. I think, and many people believe that, like Jan LeCun and other people, with the current technology, we cannot fix the hallucination problem. So we can mitigate it, but if you think we are predicting by design. So prediction by design means you will make a mistake at some point because you cannot predict everything. Because if you can predict everything, it's like you have all knowledge, you're an oracle, you are God. And of course, the systems are not that. So I think we need to add other things. We need to add, for example, can we fact check? Can we give, for example, confidence levels? I'm not sure about this. Say I don't know. I was told that ChatGPT 5.0 says I don't know sometimes, but I haven't seen it. So, and the problem is that more specific things higher the probability of making a mistake. And although this could be possible, so I'm sure I can ask. Now, for example, now ChatGPT is using much more search than before. So that's another way to avoid hallucinations. So searching to get the answer. And this is the real search. And this is what people should do too. If you have something very specific, don't ask ChatGPT, search it, and you will find it because it's very specific. If it's something generic, that's fine. But I don't understand why you want to pay also. By the way, when I don't know if you're paying or not for the chatbot, but it's more expensive for the planet. A chatbot takes 10 times more energy than a search engine. So you are wasting 10 times more energy. Why do you want to do that if you can solve it with the other way around? So also try to be green, try to be thinking on the resources that we're using, but someone is paying that energy. Maybe not here, but maybe in other places. So we have an energy problem. Today, we're getting close to 3-4% of the electricity being used on this kind of technology. If you add TikTok and Instagram, we'll be even larger. So we're wasting maybe 6-7% of the electricity in playing with tools, some cases for good, some cases for just waste time. I don't know, we need to be more conscious about how we use technology.
Thank you, sir.
Sir, what are the best practices for creating and maintaining ontologies for semantic search in specific domains like medicine, finance, or in education?
So what are the applications on this topic?
It is related to ontology.
Yeah, so
What are the best practices for creating and maintaining ontologies for semantic search in specific domains like education, medicine, and finance?
yeah, I'm getting outside a bit of my expertise. Well, education, I think, is the same problem because you need to educate in all knowledge, right? So basically, we have the same problems in education, but in other more close domains, there are other problems. Like, for example, let's say medicine. And yesterday I was talking to a company that was doing this in Spain, a triage of patients. So you need to tell a patient if they need to go to emergency or not. So how many people here have seen the Dr. House series? Okay, only one. So Dr. House is a doctor that needs to find the cause of an illness, and typically is the most strange possibility. So the number 10. So AI, what AI does? Finds the most probable, number 1. So the question is, in all the cases that you have, number 1, what is the most For example, what is the percentage for number one? Let's say it's 80%. If you have these symptoms, 80% of the time, most probably you have a flu. But what happens with the other 20%? Depends on how risky the other 20%. If the other 20% means that you will die, I think 20% is a lot. And then AI will not help them. Now you say, okay, these are two other possibilities and you get to 10%, maybe better. But it still depends on the risk of that. So this is the problem on depending on the domain. You need to understand the risk and you need to take the decision, should we do it or not? For example, for hiring people, I would say you shouldn't do it. Why? Because maybe you're making a mistake 30% of the time. Part of this time you are discriminating someone, for example, a woman, and the other percent you are favoring someone, perhaps a man. Do we want a society where 2/3 of the time the system works and 1/3 of the time basically keeps the biases of the world? I don't want a society like that. So we need to decide as a culture, as a nation, which things are okay and which things we need to keep human. And I think there are many things that are involving humans that we need to keep human. In spite of people saying we can do it better with AI, it's not true. Because the humans are solving a different problem than the machine. For example, hiring people, the human is taking in account things that the machine is not taking in account. And the machine is taking in account things that the human is not taking in account because it has more data. So that's why the mistakes are different. But I prefer the human errors rather than AI errors because sometimes AI errors are worse than human errors.
Well, problem is, I feel, with the scaling, that all this hallucination was always there, among the people. Now that when it is available for everybody through services like this, now, given that the problem is more with the kind of a economic model or development model for the developed world in a way. Services sector has to grow, innovate, and thrive. Well, this is one of the outlets. AI is one of the outlets, ChatGPT or whatever it is. So, responsible AI, as you would actually propose, means changing such an innovation model. Would that work at all?
Good question, thank you. Your question is framed on the current state of affairs. This is part of my problem. So, for example, when you say innovation, I think you're assuming that all innovation is good, which is not true. Now, we have a lot of bad innovation, but that's why we need good regulation, right? The fallacy of innovation versus regulation is a fallacy. I can send you very good papers that show why it's a fallacy, although this is solved by all the big tech. Now, scaling, I don't think is the solution. Charlie Kuhn, for example, doesn't think that scaling is a solution because scaling only gives, at some point, more problems because we get noise. We have used all human information available, good and bad. There's no more. If you use synthetic data, we get replication of that one. So scaling doesn't work. I mean, we need to do things that are different, like adding real knowledge, adding logic reasoning, and adding common sense. The common sense is the most difficult one because, for example, we can react well to situations we have never seen. So it's not about learning. Well, it's about learning, but it's maybe encoded in our DNA. So, for example, some animals, and we need to understand what is DNA, some animals, I think the best example is cats. If a cat sees a cucumber, it is afraid of the cucumber. That's in the DNA. They have never been attacked by a cucumber. Like the same happens with people. We have things in our DNA that we react not so well for things that we don't know. Like what would be a reaction to see a real alien? And I don't know why aliens are always ugly, but let's imagine you have an ugly alien, maybe you would react aggressively. But maybe it's a completely peaceful being, and for sure, they're smarter than us. Why not? So I think we need to change the system, and I will change it. But today, if you see what is happening, the main incentive in the world is greed. It's how to get more money. It's not social well-being. I think in India things are different in the sense that the Indian culture cares much more of nature and other people. So I don't have the answer, it's not my field, but I think you need to frame the question in a different way. Yes.
Some of the yes, yes, threats that you have mentioned is very shocking. But even now, Google, for example, searches they are integrating AI. For example, recently they introduced Scholarly Labs, and some the general search engine also they are using AI models
Yes.
to search results. It show that. Why when you were in LA schools, we heard about semantic search engine, semantic web, and all. Why there is no comprehensive search engine which can mitigate AI's biases, AI's threats. For example, we have a semantic scholar also, but generally general search engines we don't have which can mitigate this kind of threats. And also, is it that policies also not there to protect the users when they experience this kind of threats using AI predictive models?
Yeah, yes, we can mitigate these things, but it's good that you mentioned Google because I think they made a mistake by putting the AI summary. Because they were forced by OpenAI and Bing to add that because people like it. But putting something that people like is not a good reason to put it. Because, for example, I have seen many wrong examples in that summary. I would say that should be optional. For example, do you want AI summary? And then you are conscious that it's a prediction, for example. They should say this, maybe this is wrong, but they don't put it because they don't want to say that. They want to compete with Bing and other search engines that are using the same. So I think that Google is killing their own business by this. And this is weird. Competition, fine, but yourself is like a very slow harakiri for me. We can mitigate it, but I think the problem for search is that we should use relevant data, not predicted data. So predicting knowledge is not knowledge. You can predict something that may be true. For example, I have a friend that was looking for good papers for a project reference and asked ChatGPT, and ChatGPT got 3 papers, and he told me I cannot find the papers, and one is yours. I look at the paper, I said, wow, no, I haven't written the paper, but it's a good title, I should write it. So very good to find a new title, but it's so easy to invent these things. And each part is true. So the journal exists, the data exists, the title makes sense, the authors exist, but altogether doesn't exist. This is the problem. This is the problem of predicting things that are very complex. A woman? No question from another woman? In the red seats?
Sir, what is a semantic search or hybrid search in the context of RAG? What is a semantic search or hybrid search in the context of RAG?
In the context of RAG, what the first part of the indirective.
Semantic search or hybrid search?
I think it's the same. It's nothing different. The only problem is that putting the generative AI after the search still introduces mistakes. So even though the answer is coming from the right documents, sometimes you find mistakes due to the genetic part. And there's some very interesting research in the last year about things that are completely intuitive. Not intuitive. For example, things like if I put random documents, the answer is correct. So I can point you to these papers from Silvestri et al. On this group. So Dr. Guru, please.
Any query from student community? It is for you indeed. Anybody? From student community, no? Okay. Let me first congratulate you for your wonderful lecture, good content, and the way in which you narrated. Congratulations. And my concern is on as is because you contributed a lot to the field of information retrieval. You have moved around the globe and have seen many countries and many institutions.
95 countries.
Yes, yes, reaching century, right? So, what is the attempt that your people, especially the people in your institution, your university, towards deploying IR enabled systems in taking care of day-to-day governance activities of the institution? To what extent? And how is that document, a policy document related to the deployment of these AI-enabled solutions for day-to-day activities, especially the AI campus?
So you were talking more like agentic AI?
Maybe.
Uh,
Because today, instead of talking in terms of only general solution, we are thinking of personalized, tailored and computing machinery, right? So did you put any effort towards coming out with personally tailored IR system, especially designed for e-governancing of your institutions or your university? What is your suggestion for us to take it away towards our university or ourselves?
I think that the IR system can be very helpful in many public institutions, but the main problem is data. It's not having the IR system, and we still have the same problem. So good data. For example, I was seeing an example yesterday of data from India, and some features, very interesting features clearly were missing. So the problem is that, do we want to have a very good search system with not so good data? And maybe the answer is no, because that could be more problematic because of the results you will get. You will create new biases, and I have examples of that, like biases based on the pitfalls of the data. So if you have a place where you have very good data, yes, I would say the answer is yes. And we should.
Can you think of something which is parallelly designed and working along with the human system?
Yeah.
And
If you can,
over a period of years, it could be evolved to the extent of.
if you can have a perfect database, yes.
Yes.
But this is the problem. I haven't seen it yet. I haven't seen that. Except in a Tory problem, in a very small problem. Not like in a ministry or something up to that.
One more question. Other OpenAI or any other large language model companies that they are using data that is available on the web free. How do you see the copyright, violations or copyright issues that will be going to unfold in the future?
Can you repeat with I don't hear very well.
Sir, my question is that there are copyright violations with regard to AI, and there are OpenAI and many other companies that are using the data that is freely available, and they are passing it for AI to predict. How would you see the copyright issues in the future? Would that
That's a complicated question. So that reminds me of a paper I wrote with including one Indian author, Bhavan, about, and many people say that today we are the product, right? Our data, for example, I couldn't have Wi-Fi in the Bangalore airport because I needed to give away all the data in my passport. And I didn't want to a Wi-Fi provider. I had to do it to the Indian government, but why to a Wi-Fi provider? So many times you are getting a lot of free things, but we are giving data away. So we have the product, and in a paper we wrote that already, I would say 15 years ago, we proposed that if that's the case, there's enough money in the world to get part of the revenue. So for example, if you generate a lot of traffic for Instagram or for Facebook or for X, why you don't get part of the money? Well, you're a person that are helping the system to grow and to work. And that is possible, but of course they don't want to share that with users. But we are indispensable for this system. Without us, they don't make any business. So we should do a revolution. We must be paid for our data, and some NGOs are working on that, how to do this, and they're working on environments where they are more fair, and you being paid for the data. For example, Medium is doing that to this. Medium, if you contribute, you can get some money, not much, by people watching your contribution. So that's the future. I hope the future will be more fair and we are part of the system.
Sir, how do you evaluate the performance of RAG models in semantics?
Christina, please. No, she already did 2 questions, so.
Okay, Ricardo, bienvenido a India. Welcome to India. Welcome to Mysore. I feel you feel like this place, as I do, as my home. I wanted to talk to the students about the consequences of the use that we are doing on a daily basis regarding ChatGPT, and how me personally, one of the reasons why I took my year off was because I was using the tool, I was using it on a daily basis to do absolutely everything. So I would like you to tell us, how can we actually control ourselves from, I don't know, if there's, what is it going to be like in the future if we keep using ChatGPT to like use all our like daily, routines? What is it going to be? I mean, I could really feel my brain was shrinking after like 6 months of using ChatGPT, and I couldn't stand it anymore. And I was really worried, and I worry about the future of the students and about the future of any learner. What can we do? What can we? How to stop this? What is it going to be like in the future? That's my question.
Very, very good question. And let me tell you some stories. So when I received my BlackBerry long time ago, I was watching the BlackBerry like every time it vibrated because I was in email. And I have received hundreds of emails per day, so that would be like every less than 5 minutes I will be looking at it. And I felt like you with generative AI. And I got addicted. I was watching my BlackBerry like hundreds of times per day. So I decided that I will switch off all notifications. Since that time, I don't have notifications here. So if you call me, you need to call me 3 times, so it's an emergency, and I will answer, because then I will listen. Because I decided that it's so easy to get addicted that I need to decide when I see this device. I'm the one in charge, not the device. Today, I see that many people basically has this device as basically deciding when to interrupt you. And you see people in the street stopping in the wrong place, answering maybe a silly message that is not brilliant. So with generative AI, I felt that if I start using it, the same will happen. So I don't even start. I will only use it for examples. I don't use generative AI. I can use it, but I think I can do it better. That's first thing. Second, it's like trying to lose weight. It's hard. You shouldn't do it. But I feel better because at least I don't have any ethical issues of who did the work. I will feel really bad. There is a very recent article in Yale University that they interview teachers and students, and all the students felt guilty of using it. But they say that because everyone was using it, they had to use it. So this is the social pressure is the problem. Now, I'm sure that if a university decides not to use it, a student will keep using it because it's a competition. But that's part of the culture, that's part of the framing that we have today. For example, a student told me the other day, why do you want to help China not be in this AI race? But which race? It's not my race. Why I want to be in a race that I don't like? And he even called me a coward. Student, undergrad student, you're a coward because you don't want to fight this race. Paul, I'm a coward then, no problem. I prefer to be a coward because I don't want to race your race. And this is the problem today. We're having so much media pressure, so much social pressure that we feel that we need to do things that are wrong. We need to start by deciding to be different, to be weird, doesn't matter, to do things different. At the end, the people that learn and the people that do things by themselves, they will be the masters of the world. So with AI or not. So if you know how to use AI, use it for other things like translating, summarizing, giving ideas of what you need to write, but the writing should be done by yourself. And I think this is hard. I still haven't used it in 3 years, so I keep not using it. And I don't want to use it because I know I can be addicted. If you see the statistics in the internet, teenagers have two problems. If you are a female, the main problem is that whatever you are, the only important thing is how do you look. So the number of suicides of teenagers, females, have increased, at least in the US and the UK. This is because of the pressure of the only important thing is to be pretty, which is a mistake, big mistake. And second, what happens with teenagers that are male? Well, they're addicted to gaming, to adult stuff, and to many things that they shouldn't do. They are toxic, and then they are more addicted than for example, females. But there are many problems there because they have social issues later. So we are creating a very weird society based on the abuse of this technology. We need to use it the right way. We should control the usage. For example, say, okay, only I will use generative AI 1 hour. If you cannot say, I will not use it. And then you will decide what is the best usage of that, and probably will be the good one. So you need to be human, and humans need to control themselves.
Yes.
It's hard, I know.
You have answered the question even before. I was very recently read a book titled Digital Minimalism. So something like that, probably. Maybe AI is a kind of like people get addicted to mobiles, are they getting addicted to using, AI, tools like chatbot?
Thank you.
Sir has presented very good this, I think, lecture, very nice presentation we heard. We got a good opportunity to listen in the lecture. I think you are concentrating much on this AI. And what will be the next, I think, the technology, many of them are telling this synthetic intelligence will be shortly coming. What is your opinion about that?
Okay, so you're talking about AGI. Okay, to answer about AGI, first we need to define intelligence. That's a difficult thing. I think we should talk about computational intelligence, the different intelligence that is faster than us, can have more data than us, can analyze patterns that we cannot, and so on. But that's not superhuman intelligence. So we may do that. The question is why you want to do it. Why do you want to create Terminator, for example? Like Geoff Keaton is worried about that. Noteworthy Joshua Bengio too, lately. I don't know why we want to do that. I can answer the question in many ways. But for example, if you analyze human history, probably before that, what will happen is that some people will have use of technology with other people. We have done this in the past, colonization, slavery, and so on. Now we have this cultural colonization. I think that's one problem. So even if we can do that, probably something worse will happen in the way. Like remember, last century we almost had an atomic war. We control ourselves. We need to do the same today. We need to control AI to make sure that we don't have an AI war. I'm sure that all the top 3 militaries have robots. Of course, they're hidden. But imagine a robot that doesn't work well. Could be really dangerous. But now, even if we pass that and we get to create something smarter than us, between quotes, I wish that person would be like the Bicentennial Man. Remember this movie, Bicentennial Man? So there was the first robot that was given rights in the future because he was a human and he was a good human. But this is the best case. In the worst case, we don't need to think about AGI. We can think about very advanced aliens that come to Earth. And I saw a meme, very good meme recently that was two aliens in a UFO. I don't know why all UFOs are the same shape, very small. And one alien says, "Oh, there is life there." And the other alien says, "Don't go, please don't go, because they are killing their planet." Right? We are the parasite of the Earth. And what happens if someone more smart finds out that? I will let you answer. Thank you.
Sir, what are the different types of?
Friends, we are running out of time. We are already 1:05. So, Dr. Ricardo is approachable and you can reach him how through his email and raise any questions. I'm sure that he will get back to you through emails, responding to your queries. So please excuse us. We have to go forward because of we are running out of time. It's already 1:10 reaching. Over to the
Thank you, sir, for that insightful and intellectually stimulating lecture. To share his reflections on today's session, I now invite Professor D.S. Guru, Department of Studies in Computer Science and presiding chair of today's program, to deliver his presidential remarks.
I don't understand. You are clapping in the truth itself. Why are you clapping? The respected renowned scientist, fellow of ACM, fellow of IEEE, gigantic personality in the field of information retrieval, the one who is known for his contributions in the field of information retrievals in specific and computer science in general. The elderly person, Dr. Ricardo the Diaz, the chairperson of the Department of Chairperson of the Department of Studies in Computer Science, Professor Ranganathan, Senior Professor, a member secretary of this Sarada Ranganathan Endowment for Library Science Society, elderly personality and a well-wisher, Professor K.S. Raghavan, and my ex-colleague and well-wisher, a gentle lady, good-hearted personality, known for his effort in establishing good connectivity across many eminent scholars, Madam Shalini and the Dayas, Professor Kavi Maheshappa, Dr. Satya sir from Informatics, Professor Belliyappa, and my colleagues and other colleagues in the campus. My good friends from other institutions in and around Mysore, senior researchers, more so important, my dearest budding technocrats, dear students. A good afternoon to all of you. I assure you that I will not check your patience. I do understand it. If I continue talking without understanding your hungriness, probably I may have to face your angriness. So, but still, it's my responsibility, and I feel I'm honored and respected for you having extended an invitation to me from this Sarada Ranganathan Endowment Library Science Society to preside over the event of this endowment lecture delivered by eminent personality Dr. Ricardo. I really feel I'm expected to be here chairing this session. So, Dr. Ricardo had delivered an amazing, very informative, and indeed, he took us for a journey on a long corridor of history of IR, starting from its inception, stating that TFID of model, entity extraction, and then move towards predictive searching. And in his journey, he has not simply narrated the story, the way in which it has been evolved, but also has taken up as and when there was a possibility to warn us about how to use AI, when to use AI, when not to accept AI. And it should not be with any illusion that AI is to replace human individual, but AI is to supplement our abilities. Though the technology called AI is a demanding technology today, but I feel it is still an infantile stage that we cannot completely believe and depend upon. It has to grow up further. And in between, somewhere he mentioned that what really matters is a vector space, operations in the vector space. For intelligence, artificial intelligence, mathematics appears to be the language of AI, language of science in general, and specifically language of AI. And unfortunately, the statistics alone is the grammar of that language. Though we rely upon vector modeling, vector spaces, operations in vector spaces, but our decision making is purely based on statistical measures and outcome of the statistical measures. In my opinion, I say that statistics is the grammar of the science, and whereas mathematics is the language of science. And technology is being built upon to beautify everything, to make everything possible, right? Of course, yes, interestingly touched upon RAG models, retrieved augmented generation models, and architecture also, how it is working, why it is working, why should we take it as a model for retrieving as information with contextual data. And he has equally mentioned that look, the system works without common sense, but we do things with common sense. That's a fundamental thing. Though today it's possible for us to make the machine learn, but unfortunately we don't have any system to see that the machine thinks. So can machine think? That was the fundamental question raised by Alan Turing. So and then we have been working on that, but unfortunately today we don't have a model to make computers or machines think. So he highlighted the importance of back of concepts and everything. Indeed, I said it's a complete journey of IR. Probably for the budding technocrats students, please take up your studies very seriously and concentrate more on vector spaces, vector algebra especially, and so on. Look, the change is the only thing which is permanent on the earth. We got to get along with the changes. But can we think of this AI or information retrieval system, a really deployable solutions for our day-to-day activities? Is a challenging question. And by the end of this lecture, in a single slide, he has opened up many, many challenging issues which could be turned to be an opportunities for the budding technocrats. There are many interesting issues to be addressed. So data is must, cleaning up the data, pruning of the data, preparing the data for making the system learn on that, and then inducing what is really expected. So instead of concentrating more on a generalized solution for everything, we can now move towards specializing it personally to tailoring up a system of our interest to a specific domain. That's what. And the very good, the interesting message which I really appreciated in his slide is be humble and understand your limitations. That's what I had seen in your last slide. I really appreciated it a lot. We must see our limitations. Similarly, AI has the limitations. So AI is not to replace, but AI is, of course, we used to say it's a technology, but it has become a capability. But just because of it has become a capability, it should not become our weakness. It should be our strength, but not the weakness, to accept everything. Our strength should never turn out to be a weakness. So should not completely depend. And he quoted an interesting story that, on his own personal data, fine, and a boy committing a suicide just by discussing with chatbot, negotiating with, conversating with chatbot, a boy is committed a suicide. If this chatbot, I heard of people called Google doctors, probably you also heard of Google doctors. Doctors today, while giving prescription, Google and then recommend the prescription. If those Google doctors start using these IR systems, probably without even attempting suiciding, every patient will automatically die. And that's the scenario. So we should be very careful. As science progresses, I'm sure that the facilities would increase. As science progresses, the technology progresses, the facilities, benefits would go up. But on the other hand, there will be a pile of garbages also. There will be a handful of garbages also. But it's our awareness. We should be aware of what is really a benefit, what is really a garbage. The technology is to make things, it is to make things possible. But unfortunately, it is also being used to fake things possible. So it is our mind setup either to make use of it for making things possible or to making it of faking things possible. So ultimate responsibility is in the hand of user. Hope so. Having heard of such a wonderful, amazing lecture by this gigantic personality, I remember that we are in electronic era, E era. E is in everybody, starts with E. E is in everything, everything also starts with E. E is everywhere. I mean, wherever you go, you see E, whoever you see, everybody, there is a E. And in everything, there is a E. And he has indirectly instructed us, warned us that he is not only in everybody, in everything and everywhere, he is also in the word called end. He also begins with E. Be careful about the E. How to for what purposes, and so on. So India government has made up its mind and framed a committee to come out with such a policy related to AI applications. So I think this is what, initially as Madam raised one question, logic. Initially we were with logic-based design of AI, but today we are missing it. There's a shift from logic to non-logic. Is that the reason for having such a dangerous situations? Yeah, I've been noticing in my village, especially the people who are not attended even a single standard of education, even first standard of education, not even practiced any alphabet, but they are capable of picking up good language. They speak well in Kannada. They communicate with, in Kannada. Very well. Wonderful. Better than us, in fact. We sometimes commit mistakes when speaking with our village people. But a villager, without even attending a single lecture of his eminent teacher, He is able to pick up the language, but he has never attended any classes on grammar. Without even practicing grammar, one can pick up the language. That's what is the system is being trained. So earlier we used to teach the grammar in NLP, natural language processing. We used to clearly identify this is what is called verb, this is what is called noun, how this is what the pyramidal structure way of organizing the relationship among those words and nouns and so on. But today we stop teaching the grammar for the computer, but we just give examples of instructions, examples of sentences, the way in which a villager is given. A kid is given an example sentence for a mother, and after some years, the kid will pick up the good language. But the difference between the kid and the machine is, kid also picks up the common sense all along, but computer fails to pick up the common sense all along. Now it and for all of us to think of how can we inculcate all along, in addition to the knowledge and the language, some bit of common sense into a computing technology. Could it be an algorithmic way of expressible or not? This is a very interesting problem to be addressed. It's a still open, challenging issue. That's what in the last slide of his lecture he stressed upon. This is what the summary I just wanted to present before you all. I really feel happy as part of this event and especially to preside over this eminent lecture by a gigantic personality, Dr. Ricardo. I must extend my personal thanks to Dr. Ricardo, who has really made this presentation possible. You are really humble and could be a role model, a scientist for all of us indeed. I expect all of you to stand up and give him a big applause as a token of our respect. Be seated. Yeah. So, Dr. Ricardo, we are being glad for your contributions and your respectfully representing by my own people here in Mysuru University. Thanks for your contribution. Thank you very much. I must thank you all. Thank you very much. I thank every member of this Sarada Endowment Lecture Series Society. Thanks, special thanks to Professor Raghavan. Thank you very much. All right. Take more to the word of thanks by Dr. Harinarayana. A small. I would like to get Dr. Mahesh. Satya, please come up. We would like to present a small memento to Dr. Ricardo Baeza-Yates on behalf of the Sarada Ranganathan Endowment for Library Science, and I invite Mr. Satyanarayana, Professor Shalini Aras, who are trustees, to join me. Dr. Mahesh was here. He is also a trustee.
ಫೋಟೋ ತೆಗಿಯಲ್ಲ ನಾನು ಕರೆಯೋದು ಇಲ್ಲ ನೀನು ಒಂದು ತೆಗಿಯೋದು ಇಲ್ಲ.
Now request Professor Harinarayana NS, Department of Studies in Library and Information Science, to propose the vote of thanks.
ನಾನು ಅಲ್ಲಿ ಕೂಸಿ ಹೇಳ್ಬಿಟ್ಟೆ ಹೋಗಿಲ್ಲ ಏನದು ನನಗೆ
distinguished guests, esteemed members of the academic community and participants. It is my honor and genuine pleasure to propose vote of thanks on behalf of the Department of Studies in Library and Information Science and the Department of Studies in Computer Science, University of Mysore, and the Sarada Ranganathan Endowment for Library Science. At the outset, we place on record our profound gratitude to Dr. Ricardo Baeza-Yates, our distinguished endowment speaker for the Sarada Ranganathan Endowment Lecture 2025. Sir, your erudite and compelling lecture on semantic search has significantly broadened our understanding of the contemporary information discovery. We are deeply grateful for your gracious acceptance of our invitation and for sharing your scholarship with such clarity and depth. Thank you very much. We are equally indebted to Dr. D.S. Guru, Senior Professor, Department of Studies in Computer Science, for presiding over today's program and his thoughtful and scholarly presidential address. Thank you, sir. Our sincere appreciation is extended to Professor K.S. Raghavan, Member Secretary, SRELS, for his warm welcome address and his steadfast commitment to the vision and legacy of Endowment. His encouragement and intellectual leadership remain central to the success of this distinguished lecture series. We also express our deep gratitude to Dr. Shalini R. Aras, former Professor, Department of Studies in Library and Information Science, for her gracious and insightful introduction of today's speaker. Her enduring contributions to the LAS fraternity and her continued association with the department are a source of great inspiration to us. Thank you, madam. We are especially grateful to Professor J. Hanumatappa, Chairman, Department of Studies in Computer Science, for his hand-to-hand cooperation, wholehearted support in organizing today's program. Thank you very much. We place on record our appreciation for the faculty, researcher, and students of the Departments of Studies in Library and Information Science and Computer Science for being here and grace the occasion. We also extend our sincere appreciation to all those who have gathered here in person today, students of both departments, faculty members and various departments of the university, faculty members from other colleges in Mysore, and members of general public whose presence has added warmth, strength and significance to this program. We gratefully acknowledge the support of the University of Mysore authorities for facilitating this event. Our special thanks to the venue staff of Vijnana Bhavan, including the technical team, administrative assistants and housekeeping personnel, for their meticulous arrangement and wholehearted cooperation. We extend our thanks to the press and media representatives for covering today's program and helping disseminate its essence to a wider academic community. We are also thankful to ICD for enabling the live online transmission of today's lecture. Their assistance has allowed many of us to join virtually. We extend our warm appreciation to all those who are watching the program online for their interest and participation. We are grateful to Sri N.V. Satyanarayana, Professor Belliappa, Dr. N.G. Satish, Professor A.Y. Asundi, Dr. K. Prakash, Dr. Vasant Raju, and many more who are present here for honoring us with their distinguished presence and for lending added significance to today's program. We also appreciate the dedicated efforts of all the faculty members, non-teaching staff, research scholars, and student volunteers from both departments whose behind the scene work has endured the smooth and graceful conduct of the event. Finally, we extend our heartfelt thanks to all the invitees, participants, and members of the academic fraternity for being with us. Your presence, engagement, and goodwill add meaning and purpose to occasions such as this and encourage us to continue organizing impactful academic programs. Thank you, one and all.
Thank you, sir. With that, we come to the conclusion of the Sarada Ranganathan Endowment Lecture 2025. On behalf of the organizing departments and SRELS, I extend my heartfelt thanks to each one of you for your gracious presence and active participation. Thank you.